Werkstattschau. Here in the museum, we build aeroplanes, restore cars and motorbikes, file, weld, hammer and tap, wonder, weld and plane some more. And they say that where you break an egg, chips fall. And that's what we're going to see here. Welcome everybody to today's episode number 19 of our workshop watch, building the Fokker V.40. Today, see how spars are made. Today's topic is wing spar construction of the aircraft with a serial number 020. This is the aircraft which is currently not being certified. The second aircraft we are building of this type, serial number 021, we will follow up in the next episodes. Spring finally is around the corner. Isn't that lovely? And now, with rising temperatures, I'm able to build the large bits and pieces that go into the wing in the workshop. In our previous installment of our workshop show, we saw how we built the wing ribs. And the wing ribs have to be attached somewhere. And that in turn is the wing spars. And the construction of the wing spars is the subject of today's episode. We'll start with the front spar and then move on to the rear spar. The assembly itself takes place on a long table with wooden blocks that hold the parts in place, just like Fokker did back then. And factory photographs like this one of the Fokker F2 also shows us how spars were constructed on the inside. After the well-seasoned pine wood, selected according to certain criteria, has been sawn into battens, these must be extended. Lengthening is done by scarfing. Scarfing means that both parts are planned at the same angle so that they can be glued together. In this way, endless battens are created. This is shown here in this step. I made a special jig that allows me to clamp the buttons in and to plan one end down, so that only 1/10 of a millimeter remains at the very end. And this way the two parts can then be glued together. A sheet of paper prevents the pressing blocks from getting glued and stuck to the parts. Clamps are then used to press the two pieces together. Now it's time to wait until the glue has set. This way you can produce endless stringers, which can then be cut to the length required to build up the spar. The sewed-on scarf joints will eventually be flattened with a toothed plane. This makes sure that the transition from one piece to another is smooth and that the stringer stays equally thick at all positions. I work with West Systems epoxy resin when laminating the spar flanges. We have it here, which is of course also properly documented, mixing, whether it contains filler and so on. When gluing, the flanges are laid on top of each other so that the grain runs in a herringbone pattern. This prevents them from working against each other if they continue to dry out or absorb moisture. First, everything is coated with pure resin, so that the wood can soak up as much resin as possible. Then a mixing is made with cotton fiber and also brushed on, so that potential gaps get all filled up too. First, the coat of pure resin is brushed on. This is done over the entire length, of course. I do intentionally not use a big brush for this. This forces me to make sure I do not miss a spot. For me personally, this works best this way. Of course, it could be done faster with a bigger brush or a spatula, but I'm not in such a hurry. Once the resin is put on, one has enough time to position and to clamp it all properly together. In the summertime it is a bit more tricky. I have two different hardeners for this resin, a slow one and a fast one. Especially the fast one is rather quick, and it happened that the binding process already started in the cup, which makes the resin then tough to brush on. Therefore I prefer the slow hardener most of the time, which simply gives me more time to work on.
Und kann dann ganz gemütlich arbeiten. Ich hab's da nicht eilig dabei.
The flanges are both coated with pure resin. I mixed up another pot with cotton fibers to thicken it. This will now also be brushed on. It makes sure that potential unevennesses or gaps will be equalized with cotton fibers as a filament. It was all blended down with a toothed plane anyway, which makes it all level and flat, and therefore it is not very likely that any gaps will come to be. However, it is a load-bearing component and someone's life is suspended on it, so I will do it properly, as always. 𝔚𝔬𝔯𝔦𝔰𝔬𝔮 does it the same way with all of their reproductions. Those are the New Zealand guys for whom I have built several aircraft already. The method works nicely, and so I do it that way, for it is good. It is efficient enough to apply the cotton fibers on one side only. No need to brush on both sides. Also, a thin layer is good enough and will do the trick. And in the next step, all you need is plenty of clamps. The resin does not require any high pressure. The clamps are just making sure the parts sit and stay together and do not slip. There is no need to tighten the clamps excessively. As soon as resin starts to pour out of, you know your parts are together. The cotton fibers I added now rest between the layers and will fill up any potential gap. They furthermore have the advantage that under the slight pressure of the clamps they release resin they soaked up, which also makes sure the resin is not squeezed out. This way they do not serve as pure gap fillers, but also as some sort of reservoir to keep the resin where it is. Control is important. Always check whether the layers of the wing spar flanges rest in the right position together and didn't slip, and that enough of the resin is squeezed out. And if then some clamps are still left over, always put them halfway in between from the center out. Here we have the 4 spar flanges prepared for the wing of the Engels E.7 or Fokker V.40. Here's the front spar, and this will become the rear spar. Top, bottom, top, bottom. Hope you can see it. The bent sections where the wing tapers in airfoil height toward the tip are already laminated in during gluing up. These are the raw flanges. Next step will be to plane down the tapering towards the tip. The steps where laminations end will also be planed down, of course, to eliminate any stress jumps at those locations. This is the next that will be done. A long straight edge is used to mark out the lines along which the taper goes. It all needs to be thoroughly measured and lined up. Then the straight edge will be clamped on and fixed to make sure it does not slip. The line can then be marked. And now I show you something how to save material. No matter how careful you select your wood, there are times when you end up with a batten that unfortunately does hold a null. With some foresight in planning, such a batten must not be considered waste if you place it smartly in your wing spar. And this can be seen here. As you see, it just drops off when the taper is cut in. And as you can see, the null lays outside of the line along which will be cut eventually, so it just drops off. I hope you can see it in the final video cut, but I think so. Along those lines, all excess material can then be planed away. And this is done with a so-called rouwbank. A rouwbank is a plane that is very long and ensures that the entire length you go along gets absolutely straight. Naturally, one must not roll over the edges with the rouwbank by doing that, since the spars will be planked with plywood sheets in the end. It would be nice to maintain them square. Step by step, this way we are closing in on the line that we draw onto the spar before. Personally, I do it so that I have at least 1/2 millimeter left. This makes sure that the spar doesn't get too narrow. It can be adjusted later on, but planning the spar too narrow here would be counterproductive in the end. Rather, deal with a little bit more weight and a more massive spar beam than one that is too narrow. The so prepared wing spar beams can then be put into the wooden jig. We've seen it briefly in the beginning of this video how Fokker did it back then. We do it the same way. Upright wooden blocks are screwed onto the table in the angles required to hold the wing spars, and to those the wing spars can then be clamped and remain in position. In this case, rather build the jig 1 or 2 millimeters narrower than required. If they are too wide apart, you run into the danger of making a spar that is bigger than it fits into the ribs. This in the end requires to plan down the spar to the size to make it go through the ribs. This, by the way, was the case with the Fokker E.5 or the 8. Fokker held shares in two piano producing companies, and when those built the wings for him, at one company those wooden uprights were too far apart, resulting in a spar too big, and they had to plane it down to make the ribs fit. This was fatal. Many today believe it was a faulty design that led to the wing failures, but this was not the case. It was a sloppy manufacturing fault. And while at the topic, this working step is the crack point. I do not want to advocate Fokker here, but his designs were thoroughly thought through. And if reproductions are done properly, you have pretty safe aircraft. Filler blocks. Wing spar construction. The build now continues with the spar beam flanges being put into the wooden table jig, which holds the upper and the bottom flange via wooden stoppers. This means that the outer edges of the wing spar is determined by those stoppers in the jig. Fokker's spar are so-called box spars, which are formed by the top and bottom flanges, which are united via a plywood web that is nailed and glued on the sides of the flanges. The attachment to the fuselage frame is provided via bolts, which go right through the spar. It is of course not possible to bolt through a hollow portion of the spar. This would squeeze the plywood together and would not transfer any loads into the flanges. Therefore, the spar is filled with solid blocks at these locations. And we will now take a closer look at these filler blocks, because these are rather clever design features of Fokker wings. Here we have a raw block. It is composed of 3 boards. They are glued together so that the grain of the outer two lays in the direction of the wing spar, while the center one is upright to it. They are interlocked and cannot distort. Apart from that, they distribute all loads entering through the bolts that are clamping the main fitting to the spar evenly into the blocks and from there into the flanges. This is an unfinished raw item. When finished up, they look like this. Yeah, that's funny, isn't it? Funny parts. They always remind me of something. I can't think of it now. Oh, yeah, I have it. Cylon mothership. Anyways. The design of those blocks is phenomenal. When I saw this for the very first time, I thought by myself, heck, what they thought here. Grandpa certainly was not a stupid one. On the one hand, it is a superb material saving, and with that a reduction in weight. On the other hand, load distribution wise, something very well thought through. These 4 arms, most important of course is the massive block in the center, but those 4 arms serve the perfect purpose of distributing all forces introduced into the block via the bolts and the wing fitting evenly into the wing spar flanges. If you take a closer look at them, you can see that there are no sharp edges. All is nicely curved and rounded to provide a perfect flow of stresses from the block into the spar. To show you the benefit of the design, it could also be used like that. Weight-wise, it is a tremendous advantage. When we put the raw block on the scale, we see it weighs about 1 kilogram, 1000 grams. The same finished up only weighs a mere 300 grams. 700 grams or 70% weight reduction, and load-wise much better than the raw block, of course. Now, this is the first part with which the building of the spar continues. We put the flanges into our jig. They cannot slip outwards anymore. These blocks are now put into the proper locations and will there be glued to the flanges. And then all the other spare parts follow up. And how such a block is created, I show you now. Therefore, I have only one finished so far, so that I can take you through the steps with the unfinished one. And to do so, we go downstairs to the big drill press. Some may think it is unnecessarily long to show you the entire sequence, but my idea behind the entire workshop watch is to give you a glimpse, an idea of how long it actually takes to get some of these works done, and this only works if you see it in real lifetime. Therefore, I avoid fast cuts. This way all the holes are drilled in, leaving round curves. The remaining portions can then be cut off with a bandsaw. This leaves us with the fingers, which eventually transfer the loads straight into the wing spar beams. This is what the finished filler block looks like. A gentle Bauteil, a gentle part that is able to transform or transfer the loads which go into the filler block via the attachment bolts straight into the wing spar beams. Clever design. And how Fokker actually made the filler blocks, and that it was in this way, shows the American Service Information Circular that was done in August 1920, when one of the war reparation Fokker D7s was examined in close detail. They even took photographs that show up in this report, showing the filler block exactly like that. Most interesting in this connection is to note that license-built Fokker D7s, for instance, had other filler block shapes, which in turn is provided by the information given in their capture reports. This is one of the many interesting details that allows one who knows about it to tell a Fokker-built aircraft from a licensed-built manufacturer. And this is what it looks like eventually when the filler block is being glued into the spar. As many clamps as possible. And here you see how the thingy fits in without the clamps. It looks like this. It all fits rather nicely. Fits together wonderfully. The clamps are now added to make sure that everything sits and stays at its proper location. Picture for the forum. And one more with flashlight. One never knows how they turn out. Now, many clamps. Important when gluing it all together is that the block and the flanges are really down on the table. At the top, the filler block is taller than required. Once the glue is set, this will be planned the way to make it all level. Then, after all the other internal parts are in place, the plywood webbing comes on top of it. But no use in telling it here. You will see it later on yourself. Resin is a mean stuff. If you put a pressing block on it and forget about, you will have a hard time removing it later. Therefore, I always put some cellophane foil on top of it. Making sure all is really down where it belongs. Very nice now. All is down where it should be. And this one is in my eyesight now, so I remove it. I put it later back on again. But for the meantime, to give me a clear view of what is going on, I remove it for the moment. Important is to make sure the arms are really resting against the wing beam flanges. If not, put a clamp there. Not with brute force, just so that any gap is gone. And as always, in the moment the resin pours out, you know the parts are together. Step by step you work your way through it until everything is clamped in place. With the big blocks being glued in place, the spar already has its initial shape. I do not need pressing blocks here, since I do not use extreme force, so I don't damage the flanges with the clamps. Only so that all the parts are very close together. As soon as resin is squeezed out, you know your parts are together. I've mentioned it before. Wunderbar. Since the table floor is level and the blocks are planned to 90 degrees as well, the box bar now has got its initial shape and forms a perfectly square box. Now you will see how I proceed. Step by step all the other parts go into the wing spar, and bit by bit it becomes an aeroplane. Nice. The other day, once the glue is set, you can use the Raubank, the long plane, again to cut off any excess material of the block that protrudes the original wing spar beams. Since the long plane is very fine-tuned, it takes a while to get all the excess material off. One must not fear to cut into the wing spar beams and to make them narrower, since it is really a tedious process. Also, I still have my pencil marks from cutting in the tapering into the spars. A steel ruler is then used to see whether all is level, and once this is the case, the whole thing is planed over with a toothed plane. This is done to increase the gluing surface for the resin. Trust is good, but control is better. That the ancestors knew. And therefore, double checking and reworking what is not good yet. Finished filler block in place, all trimmed off. Looking good. Now it's a bit of a work of running back and forth, making sure the compression members that unite upper and bottom wing spar beam fit in tightly. Therefore, taking measurements at place in situ, going back to the saw, cutting, refitting, all day long. Those compression members have to be fit in by hand, since the entire spar beams are hand planned and are slightly oversized. The left and the right side is never identical, so I can't make two the same dimension and hope that it fits left and right. That's handcrafting. It needs to be fitted in place. Another very interesting detail which can be used to tell a licensed build D7 from a Fokker build one is the number of those compression members in a wing spar. While Fokker placed compression members at each wing rib position, Albatros and OAW placed them at greater distances, about every 3 ribs apart. Albatros and OAW also did not bother to add those tiny wooden stringers that Fokker glued to the sides of the compression members to increase their stiffness and provide better attachment to the plywood webs. Why do I mention this? Because we are working on the Fokker V.40, which is based on the Fokker method. We know from the American reports that internal wing spar stiffeners were at the rib locations, and we know from the manufacturing photographs of the Fokker F2, which was also a 1919 design, that the stiffeners in that aircraft were also spaced at the rib locations. My point is, when researching an aircraft that was only built in one example by a well-known aircraft manufacturer, and the source material is scarce at best, you can easily run into a trap of doing something wrong when living under the impression that another aircraft type by the same manufacturer that was built under license would look the same in every detail. Those are the joys of trying to getting things done right. So I could save some back and forth walking and measuring and cutting and fitting if I would do it the Albatros way, but there was no Fokker V.40 built by Albatros, so I have to put in so many stiffeners as we have ribs. And as soon as all compression members are in their places, perfectly fitted in, you can start drilling the lightning holes into them. When all holes are drilled, the assembly can be prepared. For this we need triangular gusset blocks that hold those compression members in place inside the spar.
Schönes, ruhiges Geschäft, ne? Mhm.
So,
So, der Martin.
Martin is gluing in those compression members or stiffeners. For this the triangular wooden strips are glued as corner gussets into place. And just so you do not wonder, I'll explain that to you now. There is a resin on with cotton as filling material, and Martin is placing the parts very gently in their position. Then we wait. We wait for the resin to begin to set. Then when it starts to get tough, we clamp it all into place and secure it under slight pressure. This makes sure that the resin does not squeeze prematurely out and remains where we want it to be.
So weit fest. Das stellt sicher, dass der Harz nicht sinnlos vorher irgendwo herausquillt, sondern da bleibt, wo er sein soll. Gell, Martin?
Ja.
Ja.
This is done all along the entire wingspan. Very calm and relaxing work. No machine noises, no stress. The only problem is the resin. When it starts to set, it is difficult to brush it on. But this is only a real problem during hot summer days. This is a bit uncomfortable then, but working together gets the job done relatively quickly. Clamps fix the wing spar beams in relation to the compression members in 90-degree angle. This is done until the glue is hardened. Once the glue is set, the clamps can be removed and we can continue building the spar. In the next step, a tiny 5 by 5 millimeter limewood stringers will be glued to the sides of the compression members. This is done to achieve a larger gluing surface for the plywood blanking that will eventually close up the spar. Except for the side planking from plywood, the first spar is now complete and can be taken out of the jig. You can put the plywood decking on while it is still in the jig, but since I want to build the rear spar at the same time, or rather parallel with the finishing of the front spar, I decided to take it out now. Ooh, tight fit, as you can see. A first simple test shows whether both sides are equally heavy. Center of gravity is also important in the rolling axis. The front spar, less plywood webs, according to this scale weighs 9,330 grams. 9 kilograms. 9.3 kilograms. That's an alright then. And here it is, the first of the 2 wing spars for one of these aircraft. A few glimpses inside of what the spar looks like before it is getting closed. There are still some uneven areas or resin that was pressed out and rests on the side of the wing beams, but this will all be equalized with a toothed plane in the end, before the deck planking comes on. I'm indeed quite happy with how the wing spar turned out. I love seeing these bits and pieces coming together and forming an airplane. And since I have decided to take out the first spar out of the jig at this point in time, I can now work on both. While the rear spar is being assembled in the jig, I can put the plywood webs onto the front spar at the same time. This saves time, and time is important. I'm not getting younger. No one does. The start in any wing spar building is done in aligning the top and bottom wing spar beams, and to measure exactly where the ribs go eventually, which is also the positions of the compression members made from plywood, where the filler blocks sits, etc. pp. This is a back and forth process and takes a while, and needs double checking all the time. Nothing worse than having filler blocks sit in a wrong position. This would not allow you to attach any fitting to the spar. Actually, the whole thing moves quicker together than expected. The rear spar, the front spar. What still needs to be done is the 2 mm plywood web that closes the spar. I will, however, not bother you with that now. I can only repeat and encourage you to also watch episode 10 of the workshop watch. There I built the front spar in the upper wing of the Fokker 𝔚𝔕7. It is in principle the same. Fokker followed one line here. We save that for now. Apart from that, the hour is already over again. Not to believe how fast things go. And therefore I will continue to keep working and to finish up the spars, and in the next coming episode I show you how the wing is assembled. At least, so is the plan if nothing serious gets in between. That's it for today's episode. See you next time. I just realized the hour isn't completely full yet, so therefore here are some more in progress sequences for you to enjoy. But since we are still together and we do have some minutes left before the hour is full, I can take this opportunity to give some words on why I do all of this here. The main reason is because I want to have airplanes. No one would make them for me unless I spent big sums on it. The only alternative therefore is to build them myself. This is how I got started with all that airplane building stuff to begin with. The deeper reason, however, is mankind is able to fly for a little over 120 years now. And for the past 100 years one can say that mankind uses airplanes which are relatively safe. Safe always is relative, of course, and some snowflakes need helmets when they leave the house. However, considering the short time frame in which we are able to build machines which allow us to go aloft, I personally regard it as one of the greatest cultural assets that mankind has produced in modern times. No, I don't want to compare it with music or similar achievements of mankind, such as science and other things, but culturally it is an incredible legacy. And in my opinion, the heritage must be preserved at all costs. And that's why I'm going to show you here how you can build aeroplanes by hand with materials and tools that existed at the beginning of aviation that work and are historically interesting. And then also preserve this cultural heritage through their existence. This is the true reason why I publish my stuff and give it away for free. I don't do all this to earn money. I don't generate any income from flying or aviation in general. Everything is financed by the joyful support of those who are interested in me showing them how it was done back then. And if you are also enthusiastic and interested in all this, then I would be very happy if you would also support the Museum of Aircraft Construction and Technical History. Be it with old tools that fit in with the times, woodworking or metalworking tools that are just laying around in your cellar, or if you have materials, wood that has grown reasonably well, from which you can cut stringers, plywood sheets or varnish, boat varnish, etc. And of course, you can also support the museum financially. We have to maintain the buildings and take care of many things. I personally put in my whole working life, but no money, because I don't use any. But the museum can use your help here. And I would like to take this opportunity to express my special thanks to many of you who have already supported us. Thank you, because without you none of this would be possible. Aircraft construction as a cultural heritage of our time is one of the most interesting things you can imagine. It combines everything that was common in craftsmanship at the beginning of industrialization. Whether it is the Kirschner, the saddler, the joiner, the carpenter, the welder, the locksmith, the tinsmith, it doesn't matter, you name it. All these traits are represented in aircraft construction in the early years, more or less. And I always say that I'm not a master of any of these traits, but I'm at least as good as a mediocre journeyman. And if these episodes of the Workshop Watch help to preserve the knowledge of craftsmanship and historical aircraft construction, then I'm delighted. If this series also awakens an interest in one or two people to build their own airplane, then I will be very happy and can only say, go for it. Spit in your hands and get started. Aircraft construction is not rocket science and is extremely interesting and satisfying, and something very special that only a few generations before us have started. It is their legacy to us. Keep it aloft.
Und das war sie auch schon wieder, die Werkstattschau des Museums für Flugzeugbau und technische Geschichte in Weschenbeuren. Besuchen Sie uns doch mal. Jeden ersten Samstag im Monat von 9 bis 18 Uhr geöffnet. Museum für Flugzeugbau und technische Geschichte, in Weschenbeuren. Wir freuen uns auf Ihren Besuch.